Hey everyone, so let's solve today's LeetCode POTD magic squares in grid. So the problem states that we means a 3 cross 3 magic square is a 3 cross 3 grid which is filled with distinct numbers from 1 to 9 such that each row, each column and both the diagonals, that means the main diagonal as well as the anti-diagonal, all have the same sum. Now we are given a row cross called a grid of integers. We need to return how many 3 cross 3 magic square subgrids are there. And while a magic square can only contain numbers from 1 to 9, this grid that we are given may contain numbers up to 15. Okay, and the length of means number of rows and number of columns can go up to 10 here. So for example, if we have the example as this, where the grid values are given in this form. So if we consider this 3 cross 3 matrix, then in this we will see we have all the numbers from 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the magic square, 3 cross 3 magic square. Now if we consider this 3 cross 3 magic grid, then we'll see like we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this case, what do you have? The following subgrid is not a, means is a valid square, but since means there it has all the distinct numbers from 1 to 9, but let's see the sum of each row. So the next condition was the sum of each row, each column and all diagonals should have same sum. So for the first row we have 9 for 13, this row has 15 sum, this row has 15 sum, this row has 15 sum, while this row also has 15 sum. Now let's see the column sums. So for this column, for these three rows, we have 47, 8, 15, 15, and this is also 15. But if we consider this particular magic square, then we have 8, 3, 11, 4, 15. So this is good. Then we have 5, 1, 6, 9, 15. So this is good. And we have 7, 6, 13 to 15. So this is good. Okay. Now let's see the anti-diagonal sum. So we see 3 plus 1, 4 plus 2, 6. So in the main diagonal, we have some 6 as well, 6 only, which is not equals to 15. Hence, in this case, this 3 cross 3 magic square is not valid and only this one is valid. And that is the only valid magic square that exists. So hence the output in this case is simply 1. Okay. So let's try to analyze the constraints, means what will be the sum based on, since it can only have values from 1 to 9. So what will be the sum of each row, each column, each sum, and let's try to make some observations. Then we will be discussing the approaches to solve it. Okay. So first constraint is like the magic constant is 15. That means each row, each column, and each main diagonal and anti-diagonals should have sum 15. How? Let's see the proof. So for example, in a 3 cross 3 magic square, using distinct numbers through 1 to 9, the sum of every row, column, and diagonal must be exactly 15. Why? Let's see the proof. So since we know like the square has 3 rows, so sum of all cells in the grids will be simply 3 into s. Okay. So if s is the sum of each row. Okay. So since grid contains 1 to 9 exactly 1, so total sum will be what? 9 into 10 by 2, which is simply 45. So this 3s will be equals to 45. That means s equals to 15. Hence means the sum of each row is equals to 15. And since all the sums should be equal, so hence all the column sum as well as the diagonal sum should be 15 only. Okay. So any valid subgrid must have row, column, and diagonal sums equals to 15. Now let's try to make another observation. Another observation is that we try to analyze the structure of this magic square. Means how will the elements be existing? For example, here we saw like this 5 is existing in the middle, and these corners have even numbers, and these middle parts has odd numbers. So can we try to make some observation and see with proof what will be like one of the possible configurations of this grid? So let's see. The second property is the center must be 5. Center must be 5. So the number in the center of a 3 cross 3 magic square must be 5. Let's see the proof for it. So suppose we have the center. We have the center. So how many lines are passing through the center? The main diagonal, the anti-diagonal, this row, and this column and this row. Okay, and this main diagonal and this anti-diagonal. There are 4 lines that are passing through it. Okay, so 4 into 15, the total sum will be simply 60. So means the sum of all numbers means 45 plus, suppose it is cutting 3 times, so plus 3 times center, because we have already included ones here. So what will have the 4 lines that pass through the central C are these 4 lines. Now the sum of these 4 lines will be simply 4 into 15 equals to 60. Now these 4 lines cover every cell in the grid exactly once except the center cell, which is counted 4 times. Okay, so they are covering each of the cells in the grid except this is counting 4 times. So it will be simply what, sum of all numbers plus means 3 times the center cell. So the center cell will be simply become 5. So hence if the center of a 3 cross 3 grid is not 5, then it cannot be a magic square. Okay, so we made two observations, that the sum of each means sum should be 15 and the center must be 5. Then only we will be able to consider it as a magic square. Now let's see the brute force approach of solving it. What will be the brute force approach? The brute force approach will be simply, what we'll do, we'll fix the top right, top left corner, and then this I will be moving from 0 to n minus 3 and j will be moving from 0 to m minus 3. And now at this I comma j as the top left corner, we'll have a 3 cross 3 grid. Okay, so we'll be having a 3 cross 3 grid. In this grid, we'll simply iterate and find out the row sums as well as the column sums as well as the main diagonal sums. And if all of them are equal to 15, then we'll simply say that this means a valid magic square, and we'll simply increase our count by 1. Okay, so this will be the brute force approach, and obviously like since we are iterating through, so it will be n into m, and for these calculations it will be order of 9, so approximately it will be constant. Suppose we have taken it as order of 9, so overall means it will be, suppose since n into m can go up to 100, so this will be approximately a order of 1000. Okay, if we account all the complexities. So this will be like the brute force way of solving it. We have not means utilize this second property that we derived, that the center must be 5. Currently we are just doing the brute force by just simply checking that the sum should be 15. Okay, so let's see the implementation. So we simply have n number of rows and the number of columns. We initialize count at 0. We move I from 0 to n minus 3, j from 0 to n minus 3, and we'll check whether the top left corner with ij in the grid is a magic square or not. If it is magic, then we'll simply increase the count. Now let's see the isMagic function. So isMagic function, what will do, it will simply, for the 3 cross 3 grid, it will find the row sum, column sum, and all the sums, and will check. Okay, so as well as we also need to make sure that all the numbers should be lying between 1 to 9. Okay, so we'll simply iterate first through the grid and see like whether all the numbers are between 1 to 9 or not. So for that, we'll create this frequency array for the digits, and what we'll do, we'll iterate through the values of this 3 cross 3 grid, which will be simply, the value will be the row and the column, the top left corner. It will be simply what? It will be r comma c plus 1, r comma c plus 2. So in this manner, we'll be able to iterate through all the values. Okay, now as soon as if value is 0 or value is greater than 9, we'll simply return false. Or if means since the frequency of this is already greater than 0, and then again we have encountered this element, that means this element is occurring 2 times. This value is occurring 2 times. So if we encounter this scenario as well, we'll simply return false, else we'll increase the occurrence of this value. Now, if we have reached this point, that means all the digits in the 3 cross 3 grid are between 1 to 9 and all are unique. Now we'll find the row sums. The row sums will be simply what? We'll find out the row sums. If it is not equal to 15, we'll simply return false. We'll find out the column sums. We'll simply iterate through the columns, and for each column we'll find out the column sums. And if it is not equal to 15, we'll simply return false. And same for the diagonal sums. We'll find out the diagonal sums as well as the anti-diagonal sums, and we'll simply return false if any of them is not equal to 15. And if all of them like are satisfied, then we'll reach this step and we'll simply return true. Okay, so this will be like the most brute force way of solving it. We fixed the top left corner and then tried for all possibilities of 3 cross 3 magic square and find out all the sums and see whether it is equal to 15 or not. Okay, so this will be order of n into m. Let's try to submit this code here. This is same code that we discussed. Means since n and m are very small, so obviously this will be getting passed. But means let's submit it once. So it runs in 0ms and like yeah, beats 100% of the solution, because like time complexity is like order of 1000 only. Okay, now let's try to utilize the second property that we tried to see. Means can we do it instead of like checking for each row, each column, and each means all the rows, columns, and diagonals? Means can we do it without checking it? Does there exist some pattern? Because we saw like 5 is in the center, so this we proved. Now we're seeing that all the corners have even numbers and all the means the middle parts have odd numbers. So does it like represent some pattern here? So let's try to analyze that. So the first thing was means we analyzed that the center must be even. Now my hypothesis is what? That the corners must be even, that the corners must be 2, 4, 6, 8, and the edges must be odd, 1, 3, 7, 9. Okay, so the standard pattern will be simply what? It will be simply we have the 5 at the center, we have the even number at the corner, and we have the odd numbers in the middle. Okay, this will be the standard pattern. So now let's try to find out how many numbers will be existing, how many like these patterns will be existing, total number of patterns, how many it will be. So what do we have? We have a 5 here, we have a even, 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 and we have a odd, 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 odd. So let's try to fix these even numbers and see like how many number possibilities we have. So the possibilities of this 2, 4, 6, 8. So total number of possibilities for this even is simply 4 here. Okay, so we'll have 4 choices here. Now suppose I put a number here. Suppose I put 2 here. Okay, so we'll have odd, we'll have even, we'll have odd, 5, odd, even, odd. And now as soon as I put 2 here, we know like 2 plus 5, 7. So we'll definitely need to put 8 here. Okay, so this position does not has a choice. It only has a single choice. Okay, now we are left with what numbers? We are left with 4 and 6. So this corner has two choices. Okay, so this corner has two choices. Two choices, either 4 or 6. Now as soon as I put either 4 or 6 here, the other position will be filled with the opposite number. Suppose I fill 4 here, so it will be filled by 6. If you fill 6 here, it will be filled by 4. And now when all of these values are filled, these center positions does not have a choice because it will be mathematically derived because we need the sum equals to 15. Okay, so these all positions do not have a choice and it will be like mathematically derived. So the total number of choices that we had was the 4 choices for the top left position, and once we fill it, then we have 2 choices for the top right position. So the total number of choices that we have is 4 into 2 equals to 8. Hence there will be only 8 patterns that exist. There will be only 8 patterns that exist which will be satisfying the criteria for magic square. Okay, so there will be only 8 patterns which will be satisfying the. So the first pattern is simply this 816 357 492, and the other 7 are simply obtained by rotating this 90 degrees or reflecting. It means taking for all combinations. Okay, just simply rotating. Suppose I rotate it by this, so it will become 4 3 8 1 6, then 7 2 9 4. Okay, so this is one of the outputs that we'll be getting if we rotate it by 90 degree on the right. So we saw like there will be only 8 magic patterns which will be satisfying the condition for magic square, and we can simply store pre-compute these and simply check for each 3 cross 3 grid whether it is equals to this magic pattern or not. Now we saw like we will be able to find out these 8 patterns. Now let's see the proof of this, that how we are sure that the corners must be even and the edges must be odd, because we proved that the center must be 5. Now let's try to prove both of these conditions. Okay, so we saw like if both of these conditions are true, then there are only 8 patterns. Okay, now let's try to prove this so that our hypothesis is true. So let's try to analyze. So the corner cell that we have is intersected by how many lines? It is intersected by 3 lines, one row, one column, and one diagonal. Okay, and the edge cell that we have is the corner cell that we have, corner cell, it will be intersected by this line, and this line. But the edge cell that we have, it will be intersected by this line and this line, so only 2 lines. And the center cell that we have, it will be intersected by 4 lines. Okay, so I hope this is clear. Now let's try to see like put a even number on the corner and see like how many numbers means how many lines it can create. So what do we want? If we fix means if we need to find these two pairs A B such that they are satisfying the condition, because we will be putting even number here and see like how many lines it is able to create. Okay, so this number will be replaced by 15, numbers will be replaced by even, and we'll see like how many pairs of A B are satisfying, and the number of pairs that will be satisfying is the number of lines that will be passing through the corner or the edge. Okay, so let's case A, the odd numbers. Okay, odd numbers 1 3 7 9, that means we'll be checking the edge cell because we are telling that the edge cell should be means odd. So if you put one number here, then it will be 1 plus A plus B equals to 15. Then means A plus B should be equals to 14. Okay, that means A plus B in this case should be equals to 14 and it should be 14. So how many numbers pairs satisfy this condition? It should be either 6 8 or 5 9. Okay, so hence there are only 2 lines that will be passing through this, means if we fix one as well. So that means since there are 2 lines and 2 lines are passing through what? 2 lines are passing through the edge cell only. Okay, so that's why this odd number can be put only on the edge cells. Let's say another odd number. So we have 3. So 3 plus A plus B. So A plus B should be 12. So what are the possible pairs? Possible pairs will be 4 8 and 5 7. Okay, so hence there are only means number 3 can only form two valid lines, and for two valid lines it must be belonging to a edge cell. Okay, because only edge cell has two intersection of a lines. Okay, so similarly we can see for 7 as well as 9 that the number of valid pairs will be simply 2, and it can only form two valid lines, and hence it will be a edge cell. Now let's try for the corner cell, case B, the even numbers. So we put 2 number as the 2. So A plus B should be 13. So what are the means the pairs that will be satisfying? 4, 9, 5, 8 and 6, 7. So since these are the pairs that will be satisfying the condition, that means there are 3 pairs. So the number 2 can form 3 valid lines. And for 3 valid lines, we know, like it will be passing through a corner cell. Okay. So obviously this even number should be put in a corner cell, then only this conditions will be satisfied. And similarly, if you try to put 4 here, then also A plus B should be 11. So these are the pairs that will be satisfying the condition. Again, we have 3 pairs, and hence the number 4 can form 3 valid lines. So similarly, we can see for 6 as well as 8. So from this, we prove that the configuration of the pattern will be simply this: even, even, even on the corners, odd on the means edges, and 5 in the center. Okay, and the total number of configurations of this, you have seen that it will be simply 8. Okay, so we can simply pre-store these 8 patterns that we'll be getting, and then for each 3x3 magic grid we can see like whether it is equals to this or not. Means the time complexity and everything will still remain the same, but we are trying to make observations and trying to solve it. Okay, based on some observations like whether some patterns exist or not. Means the brute force approach is also pretty good, but based on some observations we are trying to derive the result. Okay, so I hope the concept is clear. We'll simply store these 8 pre-computations and we'll simply call for all 3x3 matrix, and we'll see like whether it is satisfies the condition for any of these 8 matrix or not. Okay, so let's see the implementation for this approach. I hope the algorithm is clear what we are trying to do here. So what you'll do, we'll simply pre-store these magic squares in the form of a 3D vector. Okay, because we have 8 2D vectors. Okay, so we'll be storing them in the form of magic square. Now what we'll do, we'll iterate through each top left corner. We'll see like whether the center is, if the center is not equals to 5, we'll simply continue. As what we'll do, we'll simply check for against all 8 patterns. We'll check for all 8 patterns whether if it matches any of them, then we'll simply check. So if it matches any with the top left corner as grid, the current magic square that we have is simply this, and the current, we'll simply increase the count and return the count. Now let's see the magic matches any function. So what you'll do, we'll have means the magic will be simply what, it will be a 2D vector. Okay, so now we need to see like the 3x3 grid formed by the top left corner RC, whether it matches entirely with this magic. Okay, we'll move this, we'll see like whether each cell is corresponding to this magic. If it is not, then we simply magic goes false and break, and if match has become false, we will break. If after all the scenarios this match is still true, we'll simply return true. Else, if means none of the times it has become true, then we'll simply return false. Okay, so we'll be able to iterate through all the magic squares and make a one-on-one comparison, and we'll see for all the 8 patterns whether it matches any of the following, and then we'll be able to simply increase the count. Okay, so the time complexity of this approach would also be like maybe worse than the brute force, because we have n into m and then we are checking for 8 patterns. So 8, and we have a loop of 9, so 8 into 9, so it will be like 7200, order of 7200. But we have tried means developed some pattern algorithm, and if the constraints are pretty high, we'll be able to solve it still. Okay, we'll be means simply we'll be able to just from the look of a pattern, look of a grid, we'll be able to know whether it is a magic square or not, instead of like a brute forcefully taking the sum of all the rows and all the columns and the diagonals. Okay, so let's try to submit this code here and see how much time it takes to run. This is the same code that we discussed. Let's try to submit it, and then we'll be discussing the, see it obviously it performs means does not perform better, but this is one of the approaches. And like suppose someone asks you like do not do the sum, but just by the look of it tell whether it is a magic square or not. So now will you be able to say like if 5 is in even numbers are on the corner and odd numbers are on the edges, then it is a magic square. So I hope you are able to follow along with all the approaches discussed, and if you did, make sure to like as well as subscribe, and if you yet have any doubts remaining in any of the parts, then make sure to comment down. I'll be happy to respond. Thank you so much for watching.